Hey guys, tonight we're going to learn about phylogenetic trees. So many people learn best from looking at pictures and diagrams. It just helps us understand what's going on. So for the same reason, in order for scientists to determine what species is related to another species, they use a diagram called a phylogenetic tree to help them visualize and understand these relationships. The evolutionary relationship between an organism is known as phylogeny, so therefore they call it phylogenetic tree. Phylogenetic trees are essentially the same as a family tree, but this is a family tree that represents life over all of time and all of life. It shows evolutionary relationships, for example, which organisms gave rise to or are more closely related to other organisms. When you look at these diagrams, the branch tips represent existing species. So for this phylogenetic tree, we have a dog, a wolf, chicken, lizard, and turtle at the branch tips. The branches connect to the common ancestor. You can see that pointed by the arrows at what's called the nodes. Those represent where one species diverged or where it separated into two or more species. The base or the trunk of the tree begins to divide into smaller and smaller branches. Each division separates the organism into smaller groups based upon an observed physical characteristic, or maybe genetics or behavior. So how do scientists construct a phylogenetic tree? Well, just like constructing a family tree, you might want to look at records that show evidence of who gave birth to who. But we don't have that for all living things. The fossil record is incomplete and we don't have direct knowledge of the evolutionary history. So a phylogenetic tree must be inferred indirectly from data, like embryology or anatomy, say the characteristics of an organism. For example, we can look at homologous structures to help determine common ancestors. These are things like the bone structure of the arm of a human or the bone structure of the flipper of a whale. So for example, the feathers of a modern bird are homologous with feathers of fossils found in dinosaurs. In order to build a phylogenetic tree, we must identify the shared traits accurately. So in the 1970s, scientists started using DNA and proteins to help identify relatedness. This is known as biochemistry, which has allowed for more detailed phylogenetic trees. So in this picture, you've got a pretty simple phylogenetic tree. You've got the sponge, the crab, a trilobite, which is an extinct organism, and the bear. The crab and the bear are more closely related than they are to the sponge, so their lineage lines intersect first at that orange dot. It's called the bilaterians, which just means that the animals have a line of symmetry like left to right or top to bottom. This dot represents the last common ancestor of all the bilaterians. Sponges, crabs, trilobites, and bears are all animals, therefore their intersection is at the yellow dot termed metazoa, which just means animals. Phylogenetic trees are built on an x-axis, which includes relatedness. So the farther away an animal is on the x-axis from another animal, it is less related. And then the y-axis, which is time, with now, the present, being at the top, and the the past, being at the bottom. So you can see, let's take for example the trilobite. Its branch does not extend all the way to the top or the present. That's because it's extinct. It's shorter, which shows that it's extinct. So if we were to draw all living things in a phylogenetic tree, the vast majority of animals, their branches wouldn't reach to the top because the vast majority of species that have ever lived are now extinct. Hope you guys have a great weekend. See you on Monday.